Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrell's Algebra 2 class. Today we're going to be talking about quadratic equations, solving them using the quadratic formula. So far, guys, we've learned how to graph a function, a quadratic function. We know how to factor a quadratic function and use the zero product property and solve it by factoring. So we can solve it by graphing and we estimate the x-intercepts. We can solve it by factoring and have exact x-intercepts. We can solve by completing the square, finding the exact x-intercepts. And then the last way to solve, we also have the square root method, which if I don't have a b value, I can use square root method. And last but not least, I guess the most powerful of them all is the quadratic formula. The quadratic formula allows you to solve any type of quadratic function. There's going to be some pretty ugly quadratic functions out there, guys. There's going to be quadratic functions where the a is a decimal, or mixed numbers, or improper fractions, just really ugly values. That's going to be very difficult to factor, very difficult to complete the square. But if you plug these values into the formula, boom, you're done in a heartbeat. Okay? So using the quadratic formula allows you to solve any kind of quadratic equation or function once written in standard form. Remember that, it's got to be written in standard form. In fact, you could even use what's called the discriminant of the quadratic formula in order to find out how many solutions you will have before even solving the equation. Why would that be useful? Let's say you're on an engineering project and you're trying to build a bridge, and one of your colleagues comes up with an equation, a quadratic function that's going to model that bridge. You can quickly use a discriminant and see if that equation actually gives you two solutions. Does it give you imaginary solutions? Does it just give you one solution when you really needed two solutions? So it's a quick way to check to see the validity of everything. Now, one can solve any quadratic equation in standard form. Standard form, as we've talked about before, is ax squared plus bx plus c equals 0. And we can solve any quadratic function using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac divided by 2a. All right? And it's literally that easy. This is where you can use your calculator, you use all your very easy computational skills to just solve. So let's put it to use. What are the solutions of a, 2x squared minus x equals 4? The first thing we must do, gentlemen, is to rewrite this into standard form. So it's going to be 2x squared minus x minus 4 equals 0. I like to label things. I am a big labeler, okay? I suggest you do the same thing. So I'm going to label A is 2, B is negative 1, and C is negative 4. Some people disagree with me here and they say, oh, Mr. Morrow, come on. It's so easy. I can just look at it and it'll be done. You can. You're right. But I suggest you don't do that. I suggest you show yourself what you're doing. It takes just a couple seconds. So now plug it in. So negative b, which is positive 1 now, plus or minus b squared, negative 1 squared, minus 4 times a times c divided by 2a. This is going to equal 1 plus or minus square root of 1, and then I have negative 4 times 2, which is negative 8, times a negative 4, which is positive 32. 32 plus 1 is 33 over 4, and that is my answer. That's all she wrote. Now, what does that mean? That means that I have a solution at 1 plus square root of 33 over 4. And I have a solution at 1 minus square root of 33, all of it divided by 4. If I wanted the exact value for that, that's when you would use your calculator. Does that make sense, guys? Questions, comments, concerns? Easy, right? All right. Number 2. First of all, well, what I have to do here? Let's try you add 4. So I'm going to have x squared plus 4x plus 4 equals 0. Now, in this particular case, would I even really have to use the quadratic formula? Why? Because it's factorable. Exactly. If something is factorable, guys, you don't have to use a quadratic formula. In fact, I would suggest not using the quadratic formula. If it's factorable, this is a perfect square. This is x plus 2, right? So this right here is x plus 2 squared equals 0. Square root both sides, which we know how to do already. X plus 2 equals 0. There is no plus or minus because it's 0. Subtract 2, x equals negative 2. So in this case, this is just one solution. So here at my negative 2, I have one solution, and it's going to go like that. Yes, sir, you had a question, my brother.
Is there any problems where you can only solve by using the quadratic formula?
Okay, that's a great question. The question was, are there any problems where you're obligated to use quadratic formula? No. You could always complete the square. It may be nasty. So the answer is no, it's not where you can only use quadratic formula, but there are a lot where quadratic formula will be a heck of a lot easier. So there's a lot where whenever you have nasty A's and B's, that's when me personally, and you know I'm really good at completing the square, I'll say, no, forget that. I'm going to quadratic formula it. So it's not necessarily that it's, oh, you have to use a quadratic formula here. It's more that, oh, the quadratic formula will benefit me greatly in this particular case. Thank you. Great question, my brother. Yes, sir. Yes, in the case where there's a one solution, just like B. Yes, my man.
Does that mean that it was already capable of being factored to begin with?
Yeah, because it was a perfect square. That's why we factored it. We didn't use the quadratic formula. Now, let's say you get to a test, a quiz, an SAT, whatever, and you forget how to factor. Would I be able to use the quadratic formula here? Heck yeah. In fact, let's test it. Let's see what we got real quick. So this would be, first of all, I'm going to rewrite this in standard form. X squared plus 4x plus 4 equals 0. So I got negative b. I'm sorry, a is 1, b is 4, c is 4. Sorry, I'm running out of time. So negative b plus or minus square root of b squared, which is 16, minus 4 times a times c over 2 times a. Well, this is negative 4 plus or minus the square root of 0 over 2. 16 minus 16 is 0. So then I have negative 4 over 2, which equals negative 2. And guess what? We already found that before as well. So I can use the quadratic formula for any function I want. Does that make sense, boys? Okay. Like I said, I'm running out of time a little bit, but I'm going to try to run through these real quick. My A here would be what for C? My B is, and my, oh, I know. And my C is 9. Very good. Whoever said it's factorable, I don't need to use the quadratic formula here. But I'm still going to use the quadratic formula, guys, just to show you how to get it from there. So this is negative b, but you're absolutely right. On the test, I would not use a quadratic formula. Heck no. Unless I completely forgot how to factor, which happens. Sometimes you get nervous. So b squared is 36 minus 4 times a times c over 2a. And again, I'm going to get 36 minus 36 here again. So this is going to be negative 6 plus or minus 0, which is just 0, over 2. So in this case, again, x equals negative 3. I want you to realize, guys, that just because it has one solution doesn't mean you did something wrong. That means this. The a here was positive to begin with, right? Okay. So my my solution is negative 3 here, right here at negative 3. My intercept was at 9, right, guys? My y-intercept. So this is my axis of symmetry. So I'm 3 to the right, go 3 to the left over here at negative 6. I know this is a quick and dirty sketch, but in this case, I only hit the x-axis one time. Do you guys see that? Promise? Okay. For number D, you cannot factor it, unfortunately. So my A equals 1, my B equals 4, and my C equals negative 3. So negative B plus or minus, bless you, B squared, which is 16, minus 4 times A times C. See, having it labeled there really helps me out at least. I don't forget things that way. Me, at least personally. And then this is negative 4 plus or minus square root of 16 plus 12, which is 28, all of it over 2. Now we come to simplifying radicals, which we've talked about. This is negative 7 plus or minus. 28 breaks up into 7 times 4. Square root of 4 is 2. So plus 2, square root of 7, all of that over 2. I can divide that 2 to both the negative 4 and the 2 in front of the radical 7. Not to the inside of radical 7, but to the outside, as we've already learned. And then my answer will be negative 2 plus or minus square root of 7. Does that make sense, gentlemen? Still, my brother.
The description said that you could find out how many solutions you have before you even solve it.
Yes, we're going to talk about that right now. What I was asked was, he said, Mr. Moore, you said in the description of the lesson at the beginning that we can find out how many solutions we have before we even solve it. And yes, that's by using the discriminant, which is actually my next thing. What is so special about this discriminant? Well, the discriminant, guys, is of a quadratic equation or function in standard form, ax squared plus bx plus c, is the value of the expression that is inside the radical. The discriminant is defined by simply the b squared minus 4ac. You do not put it in a radical. You just take out those values. B squared minus 4ac all by itself, that gives you the discriminant. Now, what does the discriminant tell you? Well, my brothers, when you calculate that, okay, if b squared minus 4ac equals 0, that means you're going to have one solution. And we already proved that. Didn't we prove that on those factorable equations? Wasn't the radical 0? Didn't we just have one solution? And didn't it look like the graph over here where it just goes to the x-axis one time? Does that make sense, brothers? Okay. If b squared minus 4ac is greater than 0, if it's positive, that means I have 2 real roots, and that means that the equation will have 2 solutions. And you can see the graph on the right. In this particular case, why is it pointing down? Because the a is negative. Very good. And it's going through 2 different points. You cannot solve the points with the discriminant, but you will be able to determine whether or not you have 1, 2, or no real solutions. If x is less than 0, it's negative. Guys, there are no real solutions. But what did we learn about negative exponents? What kind of solutions would we have? Imaginary or complex solutions. Good job. Yes, sir.
What is this for when you're solving? Like, or not when you're solving, but like.
The question was, what is this for? We had just described this. This is to find out how many solutions we have before we actually solve it. Well, I had already explained why we need to know that. What if I want to verify the validity of a particular function? I can look at the discriminant real quick. It takes a few seconds, and you can determine if you are going to have real solutions or if the equation will render imaginary solutions. If I need two solutions and I check the discriminant and I only have one solution, I know I did it wrong and I have to go back to the drawing board, sir. So this is nothing more than just a quick check to see how many solutions you have. So if b squared minus 4ac is less than 0, that means that you have no real solutions. As you can see on the graph all the way on the far right, it does not intersect the x-axis. And then one more thing that's kind of interesting. If b squared minus 4ac equals a perfect square, 0, 1, 4, 9, 16, 25, 100, 81, that means you have one or two what's called easy roots, okay? Called easy roots. So when you have a perfect square, you may get one solution or you may get two solutions. That's the one where it really depends on the actual solution of the quadratic function. I like to just put that because it's kind of interesting. It's not in many books. So here, real quick, what is the number of real solutions of each equation? Well, I'm going to go b squared, which is 9, minus 4 times a times c. Well, I have 9 minus 72. I get negative, what is that? Negative 63, correct? Okay, guys. So how many real solutions do I have here? None. Why are there no real solutions? Because it's negative. Okay? Because it's negative. So sorry, no. Negative 56. Sorry, you mean here. Okay, yes. Sorry about that. It's still going to be no real solution. But you're absolutely right. Thank you. 9 minus, 8 times 7. I don't know what I was thinking. Sorry. It's 56. And there's still going to be no solution because that's going to be negative 47. So it's less than 0, so there'll be no real solution. Will there be solutions, though? What kind of solutions? Imaginary solutions, yes. Very good. Now, this last example here, it's a word problem. I gave you the function, and I want to find out how many t-shirts must be sold in order for the revenue to be $25,000 this week. Where do you think I would plug in that $25,000? Where the Rx is. So it would be 25,000 equals negative 0.005 x squared plus 30x. And then I would subtract my 25,000 to both sides. And then I'm going to have 0 equals negative 0.005 x squared plus 30x minus 25,000. And then I plug in my quadratic function, my quadratic formula, and I solve. You're going to need a calculator for this. In this kind of situation, you do not leave your answer in radical because it's a word problem and I need a real value. After that, guys, there's one more equation. I want you to do that on your own. I'm going to check to see whether or not you have it on Monday. Homework that is posted today will be valid. God bless you. Thank you. I hope you learned a lot and have a wonderful day. Bye-bye.